All righty, Esther, this is part two here. So we did some inequalities. Let's do a couple of these function things here. Let's take a look at number 10. If the function of n equals n squared minus 2, and we want to find the function of -6, we just go like this. -6 is now n squared minus 2, and such is life. So it's basically a fancy way of saying substitution. Now, these are a little bit more interesting. These are called piecewise functions. I'm simply going to start with the most complicated or the most complex, and then work our way. So what we have here is these are, let me double check they're all lines. Yes. So on the left, these are all lines. That's a line, that's a line, that's a line. So these are the lines. And these are the rules. The lines and the rules. Lines and the rules. So we're going to do each example, and I'm going to color code them. It's a good idea to have an eraser handy. It's really good if you work in pencil and then you use an eraser, because if you simply graph the lines and then shave it off to follow, quote unquote, the rules, you're good to go. So for example, remember f of x is essentially the same thing as saying y. So this first one, we're going to graph y equals 2. Now, normally, y equals 2 is all the points where you have a something, comma, 2. It's a straight line. In fact, it's a straight horizontal line. It usually looks like this. For example, 0, 2, 1, 2, 3, 2, -1, 2, -2, 2. And so your line for the blue there, y equals 2, is going to look like this. So technically, that's y equals 2. That's the blue. That's the line. Now, the rule says our value of x has to be less than or equal to -2. So visually, we're just going to go kind of up like that. That's where you're looking. And it's less than or equal to -2. So because it equals to -2, that means your starting point is going to be at -2. And then every point less than 2 is part of this function, which is this way. Which means, although this entire blue line is the line y equals 2, with the rule, with this rule, y is less than greater than -2. With that rule, all of this is no longer part of the graph. That's the first one. Let's do the second one. We're going to color code it. This is essentially y equals -6. Again, it's a horizontal line at y equals -6. So that is the line y equals -6. But we're only using the values of x that are greater than -2 and less than or equal to +3. So at +3 on the x-axis, +3 right there, you follow it down, you're going to have a solid line because it's less than or equal to. That equal to means solid line. But it has to be greater than -2. So at -2, you come down. Greater than means it's an open circle because it doesn't include -2. It's greater than, not greater than, and equal to. So then you take your eraser, and anything that doesn't fit the rule, you can erase. Now we have y equals -6, where x is greater than -2, but less than or equal to 3. That's what I mean by the rule. We got a line, and we got a rule. Next, we have y equals +3. That's our line. So that's a horizontal line at 3. So that would be where your line would be, y equals +3. Now the rule is the value of x has to be greater than 3. So we come here to 3. Has to be greater than 3. So we're going this way, not equal to. So technically right inside there, this is a hollow line. That should have been hollow there. And it's going to go this way. That means all of this stuff gets erased. That's why you want an eraser. It's a lot easier if you simply graph the line and then erase what doesn't follow whatever the boundaries are or the quote-unquote rule is. So that's an example. That's called a piecewise function. And them's are the rules.